Yeah, now we are going to see restricted Boltzmann machine in deep learning. So restricted Boltzmann machine is an unsupervised neural network that models data using energy-based states. Since this energy-based states is very, very important in restricted Boltzmann machine. It's fully connected bidirectional neurons. There will be multiple neurons which is connected bidirectionally. That's why it is considered bidirectional neurons. Due to this bidirectional neurons, full connectivity training is computationally expensive and inefficient in practice. So a restricted Boltzmann machine is a type of stochastic neural network used for unsupervised learning. It can learn probability distributions over input data. When we are giving some input data, it will return some probability distribution. That means some values. And the important building block in early deep learning systems, it is developed such as deep belief networks, commonly called as DBNs. So this is the comparison between Boltzmann machine and restricted Boltzmann machine. So both machines consist of only two layers, one is a visible layer and another one is a hidden layer. So key restriction in restricted Boltzmann machine is no connection between the visible units, no connection between the hidden units. That means one visible neuron is not connected with the another visible neuron, and in hidden layer, one hidden neuron is not connected with the another hidden neuron. But the connections exist only between the visible and hidden layers. So this restriction makes learning more efficient than in a general Boltzmann machine. So this is a structure. It consists of two layers. Visible layer that gives an input data which is fed into this visible layer. So another one is a hidden layer. So by which whenever we are giving some input data, it learns some features from the input data in the hidden layer. So the connection is established between the visible layer and the hidden layer. So restricted Boltzmann machine is a simplification of Boltzmann machine designed to make training feasible. So when we are need to train the feasible model, we need to move to restricted Boltzmann machine comparative to the Boltzmann machine. So it consists of visible layer and hidden layer with no connections allowed between the neurons within the same layer. It's very, very important. So RBM learns latent features from the unlabeled data. So whenever we are giving some unlabeled data, in that unlabeled data, it will learn some features. So that is called as latent features and are widely used for representation learning and dimensional reduction. So these are the two practical applications where this RBM is effectively used. So what are the features of RBM means? It is an unsupervised LG-based model that learns the probability distribution of the input data. Whenever we are giving some input data, it will learn some probability distribution from that input data. There are two layers, visible layer that is called as input layer and the hidden layer that is called as feature layer with no intra-layer connections. So there is no inter-layer connections between the visible and the hidden layer. So RBMs are trained using contrastive divergence. What is the contrastive divergence means? It's the most common algorithm used to train the restricted Boltzmann machine. So it's an approximate learning algorithm. We call it as an approximate learning algorithm that updates the weight. So the RBM learns the problem distribution of the training data. So we need to update the weight according to the input data. So for this weight updation, we are moving to the most common algorithm called contrastive divergence. So which is an effective approximation to give maximum likelihood learning. So why do we need this contrastive divergence means? So we need high probability to real training data and low probability to insert or random data. So this is the two concepts behind this RDF. Imagine you are teaching a child to draw the digit 5. So if we are showing the real digit 5 and we are asking the child to redraw it, so it will compare the original with the drawing, correct the mistake, and then after drawing, we want to compare the original with the drawn image. So correct the mistakes and repeat many times. So this is a basic example. Similarly, RBM doing the same thing. It looks the real input, reconstruct it, compares the reconstruction with the original, adjusts its weight to make the reconstruction more accurate. This comparison process is called contrastive divergence. So this is very, very important in RBM for learning phase. So it can discover latent features. So from the input data, it learns some latent features that explain the correlation in the input data. So RBMs are commonly used in future learning, collaborative learning, and dimensional reduction. So how RBM works means it's a generated stochastic neural network consisting of two layers, visible and hidden layer. The term restricted means there is no connection between the same layer, only between the visible and hidden units, only the connection is possible. So this is a diagram between the learning phase and the generating phase. Whenever we are giving some training data, The visible units receive the training data, and with the help of the parameters into data, it will learn something in the hidden layer. That is for learning phase. So generating means whenever we are giving some samples, in the training phase, it will be trained with the samples accurately. So whenever we are giving some samples in testing phase, the visible units receive the samples, the hidden units identify the features from the visible unit, and will generate the correct accurate sampling of particular input data. So this is the generating phase of the RBM. So the first one is the learning phase. The RBM learns patterns from the training data. So that means when we are giving some input data, it will learn something from the input data. That is called as training phase. So second phase is called generating phase RBM. We call it as a sampling phase. So the trained RBM. So now the RBM has been trained. So the trained RBM generates new data that resembles the training data which we have given. That is called the generating phase. So this is the RBM architecture. We will be calling as visible units T. It represents the input data. So there will be number of visible units V1, V2 up to Vn. The hidden layers also there. There will be number of neurons in hidden layers also. That is represented as H1, H2 up to Hn. It captures some latent features from the input data which is received by the visible units. So weight, the weight is associated with the connections between the visible and the hidden units. So we will call that as Wij. There is a connection between Vi and Hj. So there will be some bias. This is represented as Vi and in visible layer, and in hidden layer the bias is considered as Cj. So considering these factors in RBM, visible factors and hidden layer factors, with the help of the weight, the RBM considers some energy function. So the energy function is given by E of P from 1 by. So V is the visible layer and H is the hidden layer. So summation of I is equal to 1 to N. So the bias associated with the visible layer is obtained with Bi into Vi, and the bias associated with the hidden layer is associated with J into Cj. So these two are, we need to take the difference for finding the error correlation factor. So after that, visible layer and hidden layer along with the associated weight is multiplied with these terms and taking summation from visible layer neurons I is equal to 1 to N and hidden layer neurons J is equal to 1 to N. So the Vi is the state of visible unit I and Hj is the state of hidden unit J. Wij is the weight between the visible unit I and the hidden unit J, as already explained. So this energy function will generate some energy. So by seeing this energy, we can predict the results like if it contains lower energy, it leads to higher probability. If it contains higher energy, it leads to lower probability. So energy function is the heart of the restricted Boltzmann machine because it only constructs the probabilistic factor by the given visible and the hidden layer. So this is called as the heart of the restricted Boltzmann machine. So it determines how good or bad a particular conservation of visible and hidden neurons. So think of energy function as a score assigned to every possible combination of visible and hidden units. Lower energy is for good configuration, that gives high probability. Higher energy is a bad configuration, that gives low probability. This is why this energy function relates that lower energy leads to higher probability. So I already explained this energy function. Briefly, I have given some explanation related to Vi, Hj, Pi. Pi is a bias of visible neuron, Cj is a bias of hidden neuron, Wij is a weight connecting visible neuron I and hidden neuron J. So what is energy means? Suppose consider in physics, stable objects have low energy. So this is an example which is related to RBM I have explaining now. Stable objects have lower energy, unstable objects have higher energy. For example, the ball at the bottom of the valley has lower energy. Take a ball at the bottom of the valley has lower energy means if we are placing the ball at the bottom of the valley, there is no change or there is only lower energy will be there. So here the energy is low. So when the ball is placed on the top of the hill, there is higher energy and it will flows down to the lower energy. So RBM follows the same idea. The network tries to find configurations having minimum energy. So breaking this equation, the first term Vi into Vi is called as a visible bias term. Bias is additional value that is the activation of the neuron. Whenever the neuron gets activated, we need a bias along with the visible layer. Now, suppose visible neuron V1 is equal to 1, we are taking bias is equal to 2. Contribution is -2 into 1, we get -2. So if V1 is equal to 0, Suppose we are pressing V1 is equal to 0, the contribution is minus 2 into 0. Therefore, visible bias represents how much is visible neuron supposed to be on. So here, the first visible neuron V1 is equal to 1 is on, V1 is equal to 0, the neuron is off. So the V1 is equal to 1 neuron will have the highest probability compared to V1 is equal to 0. Suppose visible means V1 is equal to 1, V2 0, V3 1. Bias V1 is equal to 2, V2 is equal to V3 is equal to 3. Then we will be computing the second term Vi into Vi is equal to. So we need to take summation of all the bias and visible neurons, and we need to minus the total summation, and we will get some negative value minus 5. So the second term, this is for the hidden bias term. It works exactly like the visible bias term. Suppose we are taking some hidden units H1, H2, H3 values and bias of C1, C2, C3. We need to take these three values in summation, and we need to take the difference, and it will get minus 3. Hidden bias determines whether hidden neurons prefer to become active. So this is the main stage of the hidden bias. So the third term, visible neuron and hidden neuron, the weight associated with between the visible and hidden neuron, we need to multiply these three terms with measures the interaction between the visible and hidden neurons. So I have given example, and I have generated minus 1.1 as value by multiplying these three numbers. Why we need to multiply these? If all the three values are multiplied, because only simultaneously active and visible neurons in the energy, we know that one. So to finding that one, we need to multiply these three values. So if we get 0 of multiplying these three values, there is no contribution of that particular neuron. If we get some values, the contribution based on the value, it will take, when it is in high values, higher contribution. When it have low value, it will having lower contribution. Thank you.